section 11.5, we are going to be working with measures of angles that form outside of the circle. So to start off, we're going to just look over really briefly the different types of formulas we've been using so far. For the first one, we're going to draw this over on the side, and that's when you have your central angle. That has to have its vertex on the center of the circle, and the measure of the angle in degrees is going to be the same degree measure for the arc. So those are exactly the same. Then if you have an inscribed angle, the angle measure is going to be equal to half of the arc measure. So if you take the angle, that's equal to half the arc, or you can take the angle times 2, and that's going to give you your arc measure. Whichever approach you like, you can use. So then when you solve, you end up with the same answer, whether you use the first one or the second one, where 80 degrees would be the arc measure in this example. Then looking at our angles formed by two chords in a circle, remember we are using the the arcs that are across from the pair of vertical angles we're using. So that angle measurement is going to be equal to half of the two arcs added together, or the sum. So for this one, we would have half of 252, and that's going to be equal to 126 for our x value. Okay. So now here are our new situations. So for this one, an angle formed by a chord and a tangent, we are going to be able to find the measure of angle 1 by taking half of the measure of the arc AB. So for example, if the arc AB had a measure of 100 degrees, then we would find the measure of angle 1 by taking 1/2 of 100, and that would be 50 degrees. So this only can be used when you have a line that is tangent to the circle, and then the arc is cut off with a chord. So a tangent and a chord, we're going to use this. So then the next one, when we have angles outside of the circle, the measure of the angle is going to be equal to 1/2, and we're going to take the bigger arc and we are going to subtract the smaller arc. And this is going to look different, but different for different types of either segments or lines that we're using, but the equation is going to be the same for all of them. So for example, the first one, the measure of angle 1 is going to be equal to 1/2 the measure of the bigger arc, so that's going to be the one that's further away. So this one's going to be the measure of BC, and then we're going to subtract the measure of the smaller arc, or the one that's closer, and that would be the measure of arc AC. Same thing if we have two tangents to the circle. That angle that's formed on the outside, the measure of angle 2, is going to be 1/2 the measure of the larger arc. This one is a major arc, so we're going to name it with 3 letters, P, Q, R. So P, Q, R. And then we're going to subtract the measure of the smaller arc of PR. Okay, and same thing, if we have two secants, that measure of that angle is going to be equal to 1/2 the bigger arc, so this one would be arc XY, minus the smaller arc WZ. Okay, so if you have that angle that's formed outside the circle, this is the equation you are going to be using. And then if you have a tangent and a chord, we're going to be using this previous equation where that measure of that angle in between the chord and the tangent is half of the arc that it cuts off. All right, so we're going to go through and do some examples. So the first one, they tell us that the line is tangent to the circle and they want us to find the measure of the angle. So we have a tangent and a chord. So the measure of that angle that's formed in between them is going to be equal to half of the arc that it cuts off. And in this one, it's 132 degrees. There isn't much work to do. We just have to multiply those two together to get our answer of 66 degrees. Then for part B, we have another tangent and a chord. This time they give us the angle measurement of 110 and we're looking for the measure of EFD. So remember, it's the angle measure that's equal to half of the arc. So the measure of EFD. So to solve for the arc, we're going to just multiply both sides by 2 to get rid of that half. 110 times 2 is going to be 220 degrees, and that's the measure of EFD. Okay, so both of those were very similar examples, just one solving for the angle and one solving for the arc. Next, we're going to practice with angles that are outside of the circle. So that angle measure that's formed outside the circle is going to be 1/2 the difference of the two arcs. So we're going to take the larger arc, 170, and we're going to subtract the smaller arc. Oh, I wrote the wrong number, sorry. So 170 minus 72. And that's going to give us what x is equal to. So that's going to give us 98 when we subtract, and half of 98 is going to be 49 degrees. Okay, so this equation works even if you have a tangent and a secant. We're going to skip this example. We don't need to go over that. And then we are going to jump ahead to the next problem. In this one, we are going to be finding the measure of arc AB or ACB. So we're going around this outside area. We are given the angle that's in between the tangent and the chord. So remember, that angle is equal to half of the arc measure, ACB. So in this one, to solve, we're going to multiply again both sides by 2. And that's going to give us 240 degrees equals the measure of ACB. This one might look familiar. We have done this before. So we need to figure out x, and these two angles are opposite of each other. So we first need to figure out what this angle here is. So we're going to take 180 minus 52. And that's going to give us 128 degrees. So remember, when we have that angle, that is equal to half of the sum. So when the angles are inside of the circle, we're adding them together. When they are outside the circle, we are subtracting. So then when we go ahead, we're going to subtract 72 on both sides. And that's going to give us 56 equals half x. And then we're going to multiply both sides by 2, and that will give us our answer of 112. Okay. Our last example, we're going to find the value of y. We have an angle outside the circle, so we're going to take that angle and put it equal to half times the difference. So we're going to take this outside arc, or the large arc y, minus the inside arc of 30. Because our variable is inside the parentheses, we're going to just go ahead and distribute so that we can get y by itself. Then we're going to add the 15 to both sides. That's going to give us 41 equals half y. And then we will multiply both sides by 2. That gives us 82 for our y value. Okay. So those are the examples. When you get to the homework, you're going to notice there's a list on the top. These are the ones that are assigned for the homework. If you would like to do the other problems, you can. For extra practice, the answer key will have the answer for all of them. But these are the only ones that are assigned for homework. So there's only 6 problems, so make sure you're doing them. If you are confused on any of them, or you think you need extra practice, I would strongly encourage you to do a few more problems on this worksheet. All right, if you have any questions, just